Now that we're going to turn our attention to Chapter 7, and in Chapter 7 where it's about connecting shared storage devices onto vSphere. And what we're going to focus in on are storage adapter devices, storage naming conventions, hardware dependent, hardware and software iSCSI initiators, zoning and LUN masking, creating NFS shares with use of vSphere, configuring and editing hardware and uh, dependent hardware, independent hardware initiators, and then configuring and editing software initiate settings. So it seems like a lot, but it's really not a huge amount of stuff. Now, this is an important topic though because shared storage gives you so much more flexibility. I mean, if you're just looking at it from a, hey, I'm just going to keep the storage to myself, to one computer, then you don't have to worry about this. But if you have a bunch of VMs and you want them to be able to interact with each other with their data, things like that, this is one of the most important things that you can do to make a more robust system. And there are three different technologies that we really use. And then this one's kind of off to the side. But you have fiber channel, and if you remember from the last course, we talked a lot about fiber channel. We talked a lot about fiber channel over Ethernet and iSCSI. So I'm not going to go too deep into those things. You also remember that you have network attached storage. And these are different things. This is more for a hierarchical folder. I'm going to have users gather information or users open up folders and files and things like that. These are all about data between the devices and things like that. Now, over here, we're introducing the idea of these different types of technologies. Direct storage is what we talked about at the beginning, where it's directly connected to me. I don't care to share it, and therefore, this device that I'm on is the only one that can access it. Okay. Then we have fiber channel. Fiber channel, I don't know why I'm scrolling down. Fiber channel is great. It really is. It has incredible speeds. Uh, it can go anywhere from 1 to 20 gigabits per second currently. Um, it can use either fiber optic or copper cable, which would be like unshielded twisted pair. It is just a great technology. The problem is it's expensive, and that's really the rub. You have to have a fabric, so you have to maintain that fabric and have it separate from your regular network. And so we come to the idea of this one right here is fiber channel over Ethernet. Now this is great too because you have great speeds, and what it does is it takes the fiber channel and it encapsulates it into a TCP over IP type of packet, and so you can use it on your regular network, which is really nice because now you don't have to maintain and design two of them. It can go pretty fast. I mean, up to, if not faster than 10 gigabits per second. Now you do have to buy a special adapter. So the special adapters are expensive, and this would be considered a converged network because you're doing more than just one thing on that network. So the real advantage to this one over fiber channel is that it may not be quite as fast, but you're consolidating your networks. Okay, and so less maintenance, less cost, those types of things. So there is huge advantages to that. Now looking at iSCSI. iSCSI is all over the place, and often it's used. Um, One second, I just wanted to look at something. Oftentimes, it's the standard for using to link data stores and facilities. Um, that is based on IP, which is almost everything. iSCSIs facilitate data transfer by carrying SCSI commands over an IP network. So this is a great option too. And the last thing is NAS. And as I said previously, it's a file system. You can see over here, it is a file system. So if I wanted to do a share where I have multiple people adding to the same stuff, um, I'm going to use a NAS. Okay. And with vSphere, it's going to use NFS, which is a Linux Unix. So it's not going to be which is yeah, it's a Linux a network file system. And vSphere at this point doesn't really have any support for Common Internet File System, which is what Microsoft uses, or CIFS. Now that doesn't mean you can't talk to Microsoft boxes, but this is really the standard for Linux. But so the idea is if you want to connect VMs or the hosts together, they're going to use that protocol to talk to each other. Now we're going to turn our attention to the naming standards. And so I'm going to just come down in theory. Actually, it's the next page. But the naming standard that you use will depend of whether or not you're using it for a NAS or whether or not you're the other type of storage. And if it's a NAS, you just name it after the NAS device. And that's right here. If you are using NAS, your naming convention will be associated with the share name. And usually I'd name it after the NAS device. But if you're using iSCSI, for example, this is the naming convention. So we're going to talk about it real quick, and then you're going to see it in the activity that we're going to run. And so while we're talking about it, I'm going to just put this on pause real quick and start my vCenter, just so it can be getting ready for us while we're discussing it. Okay, I'm back. And so here's the naming convention here. So over here it tells you, as we can see over here, it's from a VMware kernel. And so, and one thing I need to say is this will all be the standard, but right here, you'll see all of that. Right here will be the N, and then it'll have a number, and then a C, and it'll be a number, and then the T will be a number, and the L will be a number. But the VM stands for you're using a VM kernel. Okay, that's a VM kernel. Any of the traffic that's going back and forth between hosts and storage is going to use a VM kernel port. So just so we feel comfortable with that idea, just to make sure that we know what this port is being used for. Why is the VM kernel part of the name? Why is it there? It's because we're using those ports, and it's the VM kernel is what's controlling that communication, and so we're using most likely using some of the VMware kernel's resources. We'll talk about that in the next topic. The next one is the HBA, which is the host bus adapter. Then the N is the number corresponding to the host adapter location, starting with 0. So I don't know if you guys are familiar with like Cisco switches and things like that, but um, the first section of ports is always 0. So like F0/1, F0/. This is the same idea. It starts with 0. Okay. C is the channel. Uh, always starts with a 0. The T is the target. Okay, which is the adapter on the SAN or the local device that we're connecting to. L is the logical unit number, the LUND. Okay, if you remember that. And just as a refresher, I like to think of LUNDs as almost as a volume. Okay, so it's very similar to the idea of as a volume. You have a bunch of storage devices, and we've divided those into smaller pieces. And you can also think of it as a partition, but it can span multiple devices or multiple storage devices. And so it has a LUN number to it, if you remember from the last term. You have the concatenal name, which is the network address authority ID, and it is unique identifier for the LUN. And it's going to be persistent, even if you turn off the session. Even though over here you have part of the address that is not persistent. I kind of skipped that, but that one changes. And then you have the iSCSI ID. Okay. And so we're going to go ahead and go through this this quick activity. And what it's going to do is it's going to help us see it for real. And actually, we could actually just look at the picture here, but we're still going to do it. So I'm going to bring in our VM host, vCenter in here. Now, there's not really a lot to do here. We're just going to click on hosts. And instead of going to the settings like we're used to doing, we're going to go to storage. I'm just going to click on one of these. It doesn't really matter which one. I'm going to hit path. I just did this a few minutes ago. So we hit path. You click over here, and you can actually see all this coming in. Okay, so you can see. So let me kind of bring this over here. So you can see them both at the same time. So over here you can see that we have this is VMware, the VMware kernel port. The second thing you can see, and actually let me move over so you can see the path a little better, because that's really not what I'm looking for. Oh well, I'll just explain it as I talk. I wanted you to see at the same time, but it's just not going to happen. So anyway, so we have, this is a VMware kernel port. It is as you can see, the HBA, which is going to be our host bus adapter. The N is the number, so we learn that, in this case, the N is gone, but we learned that it's the second to first one. So it's the second one over here. You can see this would be the first one. Okay. Then you have the channel, channel 0, so it's the first channel. T, which is the target, it's the first target. Sorry, I just got interrupted, so I'm not sure if I talked about the target yet. So this is the second target because it starts at 0. Then you have the logical. This is your logical link number, which is your LUN number. Okay, so you can see how what we were talking about here it really is. And so I am a big believer in touching and feeling and things like that to really experience things. Now I'm going to go ahead and move this back over. The next thing we need to talk about is the different ways to connect these. Okay, and so it's the idea of hardware dependent, then software. Okay, and so we basically have, and honestly, both shouldn't say dependent. Once they say independent, it's kind of annoying. But let's talk about what these options are. So in order to get this to work, there has to be discovery, and that's the discovery of finding the iSCSI storage and identifying the LUN. Okay, that has to happen. That's the discovery process. The next thing that should happen is this TCP offload. TCP offload is the idea that we're going to defer some of the management of TCP off of the host CPU and onto something else. And so those are the two things that have to happen from the host side, not necessarily the storage side, but the host side, to make this work. And so we have three different implementations. You have hardware, independent hardware, iSCSI initiator. You have dependent hardware iSCSI initiator, and then you have software. And what we're going to do is we're going to discuss all three of these and just make it so we understand the difference between them. Now I'm going to the real difference is in hardware. Independent means it's independent, and this is my interpretation, but independent of the VMware kernel. And so it's going to provide both discovery and offloading of TCP offload. And the reason why is because you bought this expensive card. And this expensive card will do both. It will discover the LUNs and it will take care of this offloading, which is the deferment of some of the TCP management. Dependent means I'm going to be somewhat dependent on the VMware infrastructure, the hardware. And it's still hardware. I'm still buying an adapter. I'm still buying something. That's why it's hardware. That's why both of those are hardware. But this, the card that I bought, is going to handle the TCP offload, but it's not going to handle the discovery, whereas this one does. This one will handle the discovery, but this one will not. It will have the discovery of LUNs be provided by the VMware kernel. On top of that, it will also require one of the VMware kernel ports. So it's still going to want one of the ports. This one, on the other hand, does all of that by itself. It doesn't need one of the VMware kernel ports, and it will do the discovery and the TCP offloading itself. Okay, so those are the two where you would buy a card, and really depends on your budget and what you think. Now, software, iSCSI Initiator, doesn't buy a card. What it will do is it will do all of it in software, but because it's doing a software, it's going to use the VMware kernel's processor and other resources to do that. So this means your VMware kernel is going to be doing both the discovery of LUNs and the tow, okay, which is your TCP offloading. It's going to do both. Now, it's also going to, well, I'll get into that in a minute, but it's which option you choose depends on your needs. So if I'm looking at it, I'm seeing that my VMware kernel is really bogged down, it's doing too much, then I'm going to go with one of these two options. But it's negligible. It really is. So oftentimes this is really sufficient because it doesn't add that much to your VMware kernel's workload. On top of that, it also provides the idea of the bilateral challenge handshake authentication protocol, or CHAP, which we'll discuss later on, not today, not now, but discuss later on in Chapter 9. But that's basically just having two devices ensure that they are who they think they are. Okay, and so those are the three different implementations of hardware that you can have. The next thing we're going to talk about is zoning and masking. Okay, so we're just going to go into this next section here. And so I'm going to scroll down. Zoning and masking are basically, it has the same goal, but they do it completely two different ways. So let's go back in time when we were in last term. Let me just move this over here, or the last class. Do you remember, and I'm always going to screw up the name, the worldwide name? Okay, it's a 64-bit name address, and it needs to be unique throughout the world. And the idea was, or I should say the idea here in this case, is to uniquely identify the storage processor and the fiber channel host, fiber channel host bus adapters, or the HBA. And so you'll see here we have your fiber channel host bus adapters. You have two of them, and you have your storage processor right here. And they're going to be identified with these numbers. Zoning is the idea of deciding who can see each other, and there are two different types. You have, let's see, I wanted to borrow their language. The storage administrator can configure the zoning on the fiber channel switches to control which worldwide names can see each other. Okay, and so I'm going to configure this and say, can this see this? Okay, that's what's considered soft zoning. Now, hard zoning is to do the same thing but on the port level. So over here, it determines which ports of the switch will be connected to the storage processor. So it's not necessarily see, but if they're connected or not. Okay, and so the idea is, can this person see that number, or this device which that number is connected to? Now, masking is very similar. It's all about saying, uh, let's see, it's all about saying, hey, which one, basically, can I lie? Okay, and so the idea is lying between uh, the devices. Hey, I'm going to tell you if this LUN exists or not. Now, sometimes zoning works perfectly well, but there are times where people might be able to get around it without even knowing. And we don't want people touching data they shouldn't touch. Two reasons why. One, they shouldn't see it. Two, what if they make changes to it? And that could be a big event in your company. So sometimes it's best to go ahead and do zoning, but then if you see something you shouldn't see, or someone can see something they can't see, they shouldn't see, you might need to do a masking. And sometimes you have to contact someone else, one is the storage administrator, or however your organization is designed. And to do masking, it's actually a command line command. Okay, and so uh, that's basically the idea. If you have any questions on that, just by all means, just let me know. Now, when storage is first created and is placed on the system, it will automatically be scanned, and so it will scan for the host will automatically scan for fiber channel up to from 0 to 225 as far as its numbers. So that's an 8-bit range. But if I were to make changes or I were to update, what happens is we'd have to tell it to rescan. And so we're going to look at that real quick. That's the topic of our next activity. Okay, so we're basically where we left off. And so over here, all we have to do is, here you have, I'm just going to hover over it, rescan all storage adapters on their host to discover newly added volumes. And over here you have rescan the host storage adapters to discover newly added storage devices. And so that's how you'd rescan it if you were to create, or not create, but to make changes and things like that, and you just want to update everything. And you do have to do that because it won't automatically do that when you make changes. Let's say you added storage to it or something like that. It won't automatically update those changes. So let's just see what happens if I click on here. Okay, so over here it gives me two options, or actually checkboxes, not options, and you just decide if we want both of them. So for example, scan for new volumes or new storage devices, and you just hit OK. I should have hit cancel, but it's going to go ahead and take a look at that, see if there's anything new, which is pretty cool. Okay, and so it's just a real easy, hey, let's look for, do I want to look for a new storage device? Or maybe I have created a new volume from existing storage devices. And I hit cancel because we just did that. Now we're going to talk about creating NFS shares. And so the first thing you do is you start with your device, your NAS device. And so this could be a computer that you're dedicating to being a share, or part of the computer that you're dedicating to be a share. And the overall system for this, including the device, is called the server, the NAS server. The device you're using is considered the NAS device, and so it's part of the system. Um, and so you're going to be sharing this storage area as a hierarchical folder storage area with the hosts that are on your EXI hosts over TCP/IP network, so over your normal network. You'd start, of course, with the device itself, configuring it, making sure that it's ready to go, whether it's uh, you want to connect to Windows or Linux or Unix or both or something like that. Um, you've got to configure the share first with things like host name. For example, I can have a host name or IP address, and I can even have more than one IP address. But if I do the target share, I mean, if I do for two IP addresses for the target share, it's going to be interpreted as two different shares. And so you really only want one to be identified as the target share. Know that your hierarchies or your folder hierarchies or directory hierarchies are going to be read write. Not read write. I'm sorry, I was reading something. Is going to be case sensitive. You have to make a decision of whether or not you can make the share read write or just read only. If it is read only, that's where you'd have things like your OSI files because you don't want those changed. Uh, Otherwise, if it's for file sharing, you want it read and write, and then on the folder level, you'd have the normal permissions, and you'd set those according to who you want to have um, particular access to it. You also, for VMware, you want to make sure that things are synchronous rather than asynchronous. And the reason why is we want things to be uh, said that they're completed when they're actually completed rather than saying, hey, yeah, I've completed it when it just started it or when it's initiated the process. Another thing you have to watch out for is normally when you create a share, something like that, for security purposes, you say no root squash. Root squash. Root squash is the idea that people can't have root. It protects against unauthorized people getting root level permissions on the share. Excuse me one second. You do it in this case, you might keep people from actually ever getting to the files themselves. So you have to watch out for that. Now, bear in mind though that you're not really connecting to a LUN. You're connecting to the unlike the other type of storage we're talking about. You're connecting, and like SAN is what I mean by other type of storage. Um, you're connecting to a NAS device. Okay, so we're not connecting to LUNs. We're connecting to the NAS device. Um, and you really should, like I said, determine whether or not you want read write or just read. I'd only do read if it's something you don't want someone to really touch, which would be ISO images, things like that. Okay, as I said, let's go ahead and let's create our LUND, not our LUND, I'm sorry, our NAS. And so we're going to go to storage. You could also come up here and go to storage as well. Doesn't really matter. So storage, I'm going to, most likely this will be closed on you, but we're going to come in here and hit right click it. I'm going to say storage, and I say new data store. From here, we have to just select the type. It's going to be a NAS. We have to determine which one. It doesn't really matter in this case, so I'm just going to leave it on the top, the default. We have to get a folder, and so a directory, so I'm going to say vol1, and then we're going to say db ds. The server is going to be 192.168.10, so 111.10. Do we want to mount as read-only? I'm just going to leave it the way it is. Which host am I going to connect to? This is the one I'm going to connect to. Okay, and now we're ready to complete. So you can see we have this new data store, and we're going to hit finish. So now we have created that. Okay, so as we talked about before, you have the three different ways of implementing initiators. Because remember, we have to, the initiators would be, hey, is it hardware dependent, is it hardware independent, or is it just in software? And, well, if it's hardware independent, you just install it, and there's not a lot. The discovery and everything like that's taken care of. Remember, independent means it's going to discover the LUND itself, and it's also going to handle the TCP offload, and it's not going to ask the VMware kernel to do anything. In the other version of it, and sorry, I see something's distracting me. So okay, in the other version, which is you're to be
dependent. It is this specialized card that we got. It is going to handle the offload for TCP, but it's going to ask the kernel to handle all of the discovery, and so it uses some of the processor. And it's a the system will see it in two steps. It'll see two things. It'll see the card, but it'll also see an iSCSI engine will appear once you've installed it and powered it on. And what you're going to have to do is you're going to have to configure that once that comes on, and select a port to be associated with it as far as a VM kernel port. With software, you're going to have to add special software to your system and then associate it with the VMware kernel port. You also should have a separate physical NIC for each type of storage that you're using, so that way you're not mixing them up. And so that's going to be a topic, the subject, or the next thing we're going to do in vCenter is we're going to connect those together, or we're gonna see if we can get this. That's really the last thing we're going to talk about is get the software to work. So what we're going to do is we're going to go to Manage, and from here we're going to look for Storage. Okay, so I'm over where we should be. I'm over under hosting clusters. I went on the host, and right here, as you can see, is add new storage, and right there is the one I can't click. So I'm gonna have to look up to see why we can't get there. But let's go ahead and just continue with our discussion. We'll use it. None of them theirs is grayed out too. It's kind of weird. But from here, what you do is you choose an iSCSI adapter. You'd give it a name. You give it a port. Say I'm going to inherit for the parents. Uh, you could do chap, but you'd probably inherit that from the parent as well. And so that's the idea there, is that's how you're going to create that. Okay, is you're going to, it's a real simple process. Just add it, and then you're going to say uh, any properties that you want it to have. Okay, and so the next thing we're going to do, and the last thing we're going to do, is we're going to configure port binding, iSCSI port binding. Okay, so the idea is excuse me, uh, you're going to associate a specific kernel port to a specific iSCSI adapter. Okay, and so let's go ahead and let's do that. Okay, so this one we can do. I'm going to come down and I'm going to go under iSCSI adapters. Click on that. Then I'm going to go to network port binding. Right now there is no VMware kernel port that's associated with it, so I'm going to go ahead and do that. That way they can connect through this to this data store through that kernel port. And so we're just going to choose one, management. I'm going to be breaking a lot of naming conventions, things like that. I'm just going to grab it through switch one. Hit OK. Due to direct configuration changes, rescan. Okay, and so let's go and let's do this. We can do a rescan. So rescan storage adapters. Okay, and that'll do it. So if you have any questions, please just email me and let me know.